What's up guys, this is Massey. Welcome to my channel. In this video I want to talk about Coulomb's law. As you remember, in the previous video I said charged objects attract some objects and repel some others at a distance without making any contact with those objects. So it means that electrical force is somewhat similar to gravity. Both are non-contact forces, and similar to the force of gravity, the electrical force becomes weaker as the distance between the charged objects increases. Also, electric force becomes stronger as the amount of charge on either object increases, in the same way that the force of gravity becomes stronger with an increase in mass of either object. So what is an electric force? Electric force is a force with magnitude and direction that acts between two charged particles. Which means that if you consider two charged objects so tiny that you can model them as point particles, these objects have charges Q1 and Q2 and are separated by the distance r, as you see it in this picture. So as you know, they repel each other if they are like charged, and if they have unlike charges, they attract each other. The magnitude of the electric force between Q1 and Q2 is expressed by the equation below. This equation represents Coulomb's law, which is Fe equals to K times Q1 times Q2 divided by R squared. So as you see here, with the charge of each particle, if we increase the charge of each particle, the force is going to get higher, and when we increase the distance between these two particles, we have less electric force. So Coulomb's law is saying that the force between 2 point charges is inversely proportional to the square of the distance between the charges and directly proportional to the product of the charges. And we have a constant here, it's called K. This K is Coulomb's constant, which is sometimes called K constant or Coulomb constant, and has the value of 8.99 times 10 to the power of 9 Newton meter square per Coulomb square. You need to be very careful that don't confuse this constant K with the spring constant in Hooke's law. Most physicists use the same symbol for both. The direction of the electric force. The direction of the electric force on each of the charges is along the line that connects the two charges for the case of two like charges. Now let's talk about some of the Coulomb's law, several important properties. You have already seen that the electric force is repulsive for like charges and attractive for unlike charges. Mathematically, this property results from the product Q1, Q2 in the numerator of the Coulomb's law equation. The magnitude of the force, or electric force, Fe, is always positive. In physics, it is convenient to use a negative sign to show direction, including a negative sign of the negatively charged object which imply a direction. You never include the sign of the charge when solving problems related to Coulomb's law. The electric force is inversely proportional to the square of the distance between the two particles, and the magnitude of the electric force is the magnitude of the force exerted on each of the particle. That is, a force of magnitude Fe is exerted on charge Q1 by charge Q2, and a force of equal magnitude and opposite direction is exerted on Q2 by Q1. This pairing of equal but opposite force is described by Newton's third law, which is action-reaction principle. So far, you have learned about the electric force between two-point particles. Now consider how to use Coulomb's law with more than two charges. Suppose you have three particles. One particle has a charge of Q1, the second particle has a charge of 2Q1 and is distanced 2r from each other. And what is going to be the electric force on the third charge, Q2, placed midway between these two charges? We need to solve this problem by first using Coulomb's law to calculate the force exerted by charge Q1 on Q2, then use Coulomb's law second time to calculate the force exerted by the charge 2Q1 on Q2. The total force on Q2 equals the vector sum of these two separate contributions. This combining of two forces is an example of the superposition principle. The superposition principle says that the total force acting on Q2 is the sum or superposition of the individual force exerted on Q2 by all the other charges in the problem. Remember that force is a vector, so be careful to add these forces as vectors. This means that for charges not on a straight line, the solution requires some trigonometry involving triangles or the use of vector components. When all charges lie in a straight line, the superposition principle simplifies so that you can add or subtract the various individual forces to or from one another to obtain the resultant or the net force. So now if I want to summarize the whole video, can say that according to Coulomb's law, the force between two-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. Coulomb's law applies to point charges and to charges that can be concentrated equivalently in points located at the center. There are similarities between the electric force and the gravitational force, and the superposition principle states that the total force acting on a charge Q is the vector sum or superposition of the individual forces exerted on Q by all the other charges in the problem. So this is the Coulomb's law. I hope you enjoyed this video. Please leave me a comment if you have any question, and I get back to you as soon as possible. If you found this video useful, please like it, and you can also subscribe this channel to have access to many other videos regarding math, chemistry, and physics. Thank you for watching and have a great day.